Here are solutions to homework set number 1 for ECE 476-676. This homework set looks at Python programming. Now, Python might be a new computer language for you. If you're familiar with MATLAB, you pretty much know Python. It's very, very similar. The problems here, just kind of give you an idea, a little bit of practice using Python, solving some engineering problems. If you go to the shell window, it looks like the command window in MATLAB. You can type in numbers and use it basically like a calculator. So for example, let's use Python to find the resistance between A and B. I need to look at resistors in series and parallel. So the 300 and 400 are in series. They add. Call that R1. That's in parallel with 700. Take R1 in parallel with 700. The equation for that is 1 over R1 plus 1 over R2. Take the inverse. This together is 350 ohms. Take 200 in parallel with 600. Call that R3. Equation for that is 1 over 200 plus 1 over 600. Take the sum, take the inverse, that's R3. This is 150 ohms. So this is 150 ohms. This is 350. Add the two together, I get the series resistance. R4 is R2 plus R3, 500 ohms. Take 500 ohms and parallel with 500 ohms, add them up. I get 1 over R4 plus 1 over 500 gives you 250 ohms. Take that 250 ohms, add it to 100 ohms. 250 plus 100 is 350. That's the total resistance using Python. Let's use Python to calculate I1, I2, I3. Now back from circuits, the equation for current division is what I'm measuring, 1 over R1 over the total resistance, 1 over R1 plus 1 over R2. Now to do that, I need another resistance looking right. So this resistance looking right is 25 ohms in parallel with 40 ohms. R2, that's that resistance. R1 is that resistance looking right, is 15 ohms in parallel with R2 plus 4. That's R1. The total current draw then is I'm not really sure why I calculated R1, but I did. The current I1 then is just 1 over 15 divided by the total admittance. That'd be 1 over 15 ohms, and this resistance looking right is 4 plus R2. It's that percentage of 10 amps. I1 is 5.6 amps. The remaining current is 10 minus I1. This is 4.36 milliamps, or 4.36 amps. To find I2 then, I do current division. It's what I'm measuring, 25 ohms, over the total admittance, 1 over 25, this together is 40, plus 1 over 40. That percentage, 4.36, gives you 2.68 ohm, 2.68 amps. I3 then is just 4.36 minus 2.68, 1.67 amps. So there's the currents, I1, I2, I3, using current division, solved using Python. Using voltage division, I can find the voltages. If I knew V2, I could find V3 by voltage division. It's 45 divided by the total resistance times V2. If I knew V1, I could find V2. It's all this impedance over 4 plus that impedance. If I knew V0, I could find V1. So that's where I need those resistances, probably why I calculated it in the previous problem. This impedance looking right is 45 ohms, kind of obviously. This impedance looking right is 35 ohms in parallel with 50 ohms. That's 20.58 ohms. This impedance looking right is 25 in parallel with that mess, 4 plus R2, 12.3 ohms. The voltage then, by voltage division, is R1 over 3 plus R1 times 10. 8.05 volts. V2 is R2 over R2 plus 4 times V1, 6.7 volts. V3 is 45 over 45 plus 5 times V2, 6.06 volts. And using Python as a calculator to find the voltages. Finally, Python can handle complex numbers just as well. If I do 50j, that's j50, 22 plus 40j is 22 plus 40j. To simplify this circuit, I need to add resistors or impedances in series and parallel. Put this together, that gives you Z1. Z1 is 60 in parallel with minus J80. So that's 1 over 60 plus 1 over minus J80 gives you 34.8 plus J28. That's right here. J50 in parallel with 70 is 1 over J50 plus 1 over 70, 23 plus J33. That's Z2. Total impedance, Z3, is J40 plus Z2 plus Z1. All this together is 62 plus J44. Z4 is 90 minus J10 in parallel with Z3. That's 1 over Z3 plus 1 over 90 minus J100. Take the inverse. All this together is 62 plus J8. In series with 30 is add 30 to it. The total impedance is 92 plus J8. So that's using Python as a calculator. It's very similar to MATLAB. Just type in numbers and I can use it to calculate voltages, currents, impedances. Handles real numbers, handles complex numbers. Very similar to MATLAB. If you know MATLAB, you pretty much know Python. And that's homework set number 1.